I appreciate all of you being here online with me right now. And so I know that your time is precious. So let's get straight to it, my friends. Let's go as fast as we can. My name is Josh Long. I work on the Spring team. I'm a Spring developer advocate at VMware. I'm a Kotlin GDG. Very proud of that, right? I'm a Java champion. And I have Twitter and email. And if you have questions or comments or feedback or whatever, even though our time is short, you can reach me there on those different places. And so I encourage you to do that. Now today, my friends, we're going to take a look at a lot of different things. We're going to just look at Kotlin. Now Kotlin is this very amazing programming language. Kotlin is a language that was, it's not new, right? It's a 10-year-old language. It's been around forever. And yet I think a lot of us don't really know about it, right? And part of the reason is because if you're doing server-side code like I do, it may not have been as obvious for you that this is a great language to use as it is, for example, for those who are doing Android and mobile code. You see, Kotlin is already the second most popular language on the JVM. It's already leaps ahead of everything else except for Java itself. And who knows, maybe one day it'll even overtake that. And the reason it's so popular in Android is because it's a very, very nice language and has great support for asynchronicity, which is what you need when you deal with things like the painting event loop on Android, and it's backwards compatible. So you can write Android applications using a syntax, using a language that feels like it belongs to the future. It feels like Java, 30, but it's actually here today. And even better, it compiles backward compatibly to older versions of Kotlin. So what we're going to do, my friends, is we're going to just look at the language, and I'm going to take a brief digression to talk about something that isn't related to Spring. I love Spring. We're going to talk about Spring, don't you worry. But that's not the only thing we're going to look at, right? Now, one of the things that I just mentioned is that people use Kotlin and Android, and that's where it got started. When I was first invited to the Kotlin Conf, the first Kotlin Conf, way back in 2017, which doesn't seem like that long ago, does it? But it was a long time ago, or it doesn't seem like that. It doesn't feel like it should be that long ago, and yet it does feel like a long time ago. I was invited in 2016 to present at this first event, and I was so excited to have this opportunity. Maybe it was 2016. I was so excited to have this opportunity because, you see, my friends, I live in San Francisco in the United States, and this was being held in San Francisco in the United States. And I was so excited to go home because I used to travel before the pandemic and all this craziness. I used to travel. And so I was very excited to have the chance to go to San Francisco and sleep in my own bed and see my family and so on. And so so when Heidi from JetBrains said, hey, would you like to come speak at this conference? I said, thanks. Yeah, sure, buddy. I'd be glad to see that. And I'd be happy to see him and all of my friends in the Kotlin community. Then I get to this show. My goodness, it was huge, like 1,300 people, 1,500 people, almost no advertising, no budget, no nothing. And it was huge in San Francisco. And I didn't know what they did. I didn't know how they did that. And then I realized, oh, they had Google I/O. And when they had Google I/O, they announced support for Kotlin. And that was it. That people were already using Kotlin in the Android ecosystem, but now here was Google saying, we want you to use it. It's not officially endorsed. We're not recommending it yet, but you can. And if you want to do it, it's supported. Big deal, right? Huge. Now Google, not just JetBrains, which is a big company for sure. It's a very successful company, but now Google is putting their weight and their support behind the language. Already this conference was big, and it got bigger and bigger and bigger. And the big part of that, of course, is this Android community, right? They're using Kotlin in force. They're using it all the time, even if on the server side it wasn't such a well understood thing. Around the same time, the Spring ecosystem started embracing the language, and so we started adding support here on start.spring.io, and you can see even now there's Kotlin there. And all that while, all at the same time, the Kotlin Android system. The Kotlin ecosystem got bigger and bigger and bigger. And now you can do almost anything with Kotlin, right? You can write your build files with Gradle and Kotlin. You can write web applications using Spring and Kotlin. And you can do native code using Kotlin native. And that's one of those things that we're going to actually look at right now, right? Because I think Kotlin native is perfect, just awesome, right? So native. And what else can you do? You can also you can transpile your code into JavaScript using Kotlin.js. So you have this amazing opportunity here where you can have one stack, one language to satisfy them all. Now, what we're going to look at here is something called Kotlin Native. Kotlin Native is actually a LLVM-backed compiler linker toolchain, right? It's actually a way to take your Kotlin code and turn it into native code. Now, you can't take any Kotlin code. It doesn't work for everything, obviously. Your Android applications are still going to run on Dalvik on Android, and your server-side JVM Spring applications will still run on the JVM in Spring, or GraalVM maybe. But this, if you're willing to write your code using the Kotlin programming language, then you can do some amazing things. You can actually build an application that talks to native APIs. So what I'm going to do is I'm going to go to my new native application here that I just checked out. I just built inside of the IDE, and I'm going to open up and create a new file. Okay, so here's native main, and here's my main class. Now let me make that font a little larger, my friends. I'm sorry about that. I realize that's a little small. Here we go. You know what we can do? We can make this screen just a little bit better. There we go. Hopefully you can all still see that. Okay, so now I've got a main function into my application. Already you know something about Kotlin, right? If you haven't seen it before, now you've already got an idea of what a main function looks like, a main element. So notice that there's no class here. Kotlin is a language that originated on the JVM, and you would think, since Java requires classes everywhere, that Kotlin would too, but it doesn't. Look at this. It just works. Okay, so now I've got a function. This function, it starts with a fun keyword. It's a main function. You can describe arguments. You can say that there's an argument array of string. That's fine, right? But this is no longer required, right? For the last couple of years, I think, it's been gone now. You don't even require it. So here's a hello world, right? But you can do some very interesting things beyond just hello world, right? So let's run this code. Whoops, cancel. Let's just run that, compile it. Run this. Okay, and you can see it takes a little bit longer than your regular JVM code because it's going to actually compile to native code, which I think is just amazing. Now, one of the real powerful parts about this is it is native. It's actually, you can talk to POSIX, you can talk to native APIs, right? And so that's what we're going to do here very quickly. We're going to write a little program that reads data from a file, right? So file equals, and I'm going to use POSIX, P-O-S-I-X APIs that are low level that you could talk to from C or Rust or B or C++ or whatever, right? And so I want to use fopen. That's, you see it says platform.posix.fopen. And the file, by the way, that we're going to use is just going to be right here. We're going to say echo hello Kotlin. Here I'm going to, greetings. Okay. There we go. It's just on the desktop there. And so I'm going to open up this desktop thing. So already I've got a few things that I need to care about. Already I've got a few concerns that I need to address. First of all, I need that path, right? I need actually to open up that path. So the question is, how do I decide what that path is? Well, I am going to need to find the home environment variable, first of all, right? Well, again, here, I can just use C APIs. If you've ever used C, then this is all going to be very familiar. If you've only ever used Java, then this stuff will feel a little different, right? But it's very interesting. In Java, when the designers created the language, they said, we're going to do everything from zero. We're going to start from brand new, and so on. Huh? Who's calling me from Romania? Okay. Somebody's calling me from Romania. Okay. In Java, we said we're going to do everything from zero, right? And as a result, everything is, I think, a little bit more elegant, a little bit more clean. But the problem is that if you've just learned Java, you don't know about all these amazing low-level APIs that people have been using for 20, 30, 40, 50 years, right? So one of those environment APIs is getenv. And you can see this is already a problem, right? So imagine if I wanted to use this, right? This is not actually a string. It's giving me a pointer, but you can see that Kotlin gives me a way to describe that. So what I want to do is I want to turn it into a real string. But the problem is I don't know if it will be real. I don't know if the pointer will be null. So if I try and call a dereference operation on it, it says you can't do that because it doesn't know if it's null or not. You see that? Isn't that interesting? The language has already stopped me from hurting myself. it says, hey, this might not have a value, so I won't let you dereference it without actually taking responsibility for the result. So it says you can do a safety reference like this, right? And that question mark means go ahead and dereference it even though it might be null, okay? That means I'm asserting that it's gonna work. If it's still null, I can provide a fallback value of just an empty string. So I'm actually doing a very interesting thing here. It's just one line of code. And we're not even just a few minutes into the presentation. So now I have an actual string, and what I want to do is I want to build a function to read the data from that file. Okay, so lines. We're just going to build a little function here called read lines, and we're going to provide a string that that has the full path to my file. I can use string interpolation here, right? I can do string interpolation, desktop readings, all right? And that's the entire thing. And then I'm going to build a little function that returns a value of type list, okay? So it's a collection of type list of string. Now this is not a Java list, it's just a list. There are certain types that are aliased in Java to list, and in Kotlin native and Kotlin JavaScript and so on, they get alias to other things as well. So now the compiler, or rather the tool, the IDE, can see that I'm trying to create a function that takes a string and returns a list. So I'll go ahead and do that. And we've already got another interesting feature. Look at this. I'm supposed to return a list of strings. That's the return value right there. And yet my compiler is not upset with me, right? I'm not returning a list of strings. Already the compiler is doing something that Java does not do. What it's doing is it says, this is an inline macro, and there's something special about it that the language knows about, that we don't know about, that is making it happy. Watch what happens when I remove this. See that? Already I get a little squiggly red error. That's the compiler, that's the language telling me that there's a return value that I have to return. I have to do this, right? I can return an empty list, but I've got to do something. I don't have to do that if I have this. And the reason I don't have to do this is because this function is special. This function returns nothing. In Kotlin, nothing is kind of like void in that it returns nothing, but it's also different because it means it never returns, right? So when the compiler sees nothing, it knows that it does not return. And it's also an inline function, so it's cheap to invoke. So it's a very useful thing to do, just to put that there to keep the compiler happy from bothering you, right? So, okay, we are going to actually do some work here. Let's actually read some data into memory. So val file equals open, and then we're going to take the path, or sorry, the name, and we're going to read it into a memory, right, into a string. So we'll say f open, and once I have that, I want to read it into a buffer, but this is native code. So I need to actually dynamically allocate data storage for native data, right, for actual native memory. So, just like in C++ or anything else, right? So I'm going to do something here, and let's see. What am I doing? I want to create some lines. So I'll say lines equals mutable list of, okay? It's a mutable list of strings, okay? And once I've done that, I want to read some data in, but I need to dynamically allocate an array to store that data. And so I could use Kotlin's native things, but this is actually going to be data that's going to be passed into native code. And so I have to use native functions to do that. And because I'm doing dynamic stack allocation, I need to have pointers, right? And I need to garbage collect that. And so obviously Kotlin in Java and Kotlin on JavaScript, they have garbage collection. But here, if we're using native C++ and C and so on structures, we need to make sure that we dereference or decrement the memory. We need to do our own garbage collection. So we can do that with this very convenient scope. So we're going to say buffer length, right? So 64 times 1024, right? And once I have that, I'll create a buffer. And the buffer, I'm going to allocate dynamically. It'll be a buffer for byte var. And I'm going to allocate it buffer len. Okay. Alloc array, buffer len. There we go. And now, once I've done that, I'm just going to read the data in while true, right? I'll just read data. And again, this is pretty straightforward. If you've ever used some other programming language, you've probably seen while loops and things like this. So val next line equals string, val next line, it's going to be a string. And this is me telling the compiler that this string could be null. That's the question mark. I'm saying it's a nullable field here. So I'm going to read in the next line, and I'm going to say, okay, call fgets. That's the function to read one string from the buffer. How much do I want to read? Well, I want to read buffer len, and I want to read from this file, and I want the whole thing to be turned into a k string, right? So there's this k string. Okay. So now I've got a next line. I'm going to say if next line should equal null, or nice Kotlin extension function here. If it's empty, then break, right? So that's how you get out of this loop. Otherwise, I want to keep the line and just add it to my buffer. So add that there, next line, right? Good, very simple loop, very simple logic, but very convenient, right? I've got this nice memory scope thing. So a lot of the danger that you get from native code isn't there anymore. Kotlin native is a better C++, a better Go. Now, of course, I still need to close that file, so I can use some really nice features of Kotlin, like try and finally, right? So let's say try finally. And get rid of this. And I've got this file up here. I need to close that. I want to make sure that I get that done eventually, so I can say fclosed file, right? Super simple. Couldn't be easier. And yet, it works. And so now, these lines, I can just return the lines, and the compiler is happy as well. So, lines. Good. So there's my native code. I've got the readLines function. Now I can use those lines. I can visit each one and do something with it. I might just print it out. I might, trim it, whatever. So I can say map.it.trim. I still have access to all these very convenient functions for strings, even though there's no native string type here, right? It's just Kotlin giving me one. Okay, so now let's run this program and see what we get. Now I know that you didn't come to see somebody talk about POSIX, right? This is 2020. You probably, hopefully, get that POSIX is a thing, right? So there, I printed out the lines, and if we add more, echo hi Kotlin to greetings. Salut Kotlin and me how Kotlin. There we go. So now we've got a number of different greetings there. And we can run the program again, and you can see it's getting out the lines. So I know that you didn't come here to see me talk about POSIX APIs. That's not why we're here. What I want you to see is that Kotlin makes things, because Kotlin, the language, is so pragmatic and so useful, and because the ecosystem has been built on making it the best language for everybody, it works really well for a lot of different use cases. And so let's take another look at an example, this time on server-side using Spring. Now, Spring is a framework that allows you to do all sorts of very interesting things on the server side: data access, web services, microservices, all sorts of things. But one of the things that's really nice is that you can use Spring reliably. There are APIs that have been around in Spring for 18 years, and they don't break. We don't break things in the Spring community. The code is very well written, and so it's very forward compatible. So what I'm going to do is I'm going to write an application that takes advantage of some existing APIs to build a service. Okay. Now, you know what happened here? There's a new version of the Spring framework. So I'm downloading all that right now. Awkward. Oh my goodness. Come on, Mario. Go faster. Can you see that? Indexing dependencies. Updating indices. Oh. Come on. It's past midnight in my time. So of course things re-index after midnight, right? You get the new snapshots and all that stuff. Oh, yo. Almost there. Come on, Mario. Go faster. I'm not sure if you can see that. That's Mario from Super Mario Brothers, Oh, awkward. Well, anyway, while that's loading, okay, it's coming to life. Good. And what I want to do is I want to take advantage of some existing APIs and some new ones and mix them together. So this is a regular Spring Boot application, but what I want is my Spring Boot application to talk to a database, right? So I'm going to go to my build and add in a Postgres SQL driver, okay? Database, Postgres, okay, good. And I'll add a, I want support for building JDBC applications. So I'll add in artifact ID, Spring Boot Starter JDBC. Okay, good. And one more thing, I want JetBrains' exposed ORM, okay? So artifact exposed Spring Boot Starter. There we go. Now, I have these libraries in the class path. These are just regular libraries. 3 of these, like the support for JDBC in Spring, again, very old. It's been around for decades, right? Oh, I also need the Maven repository for exposed. So let's take that from here, copy and paste, and paste it from there. And voila, okay? So now Maven reimport, reload. Okay, so now I have a basic application, and what I want to do is I want to build an application that talks to a database, and I can do this because the Kotlin ecosystem is rich with nice APIs that are pragmatic and that work with existing things. Exposed is an example of this. It's using JDBC. JDBC is a very old API, but it has a nice new feel when you use it from exposed. So what I'm going to do is I'm going to build an exposed application that requires a little bit of information to talk to my customer table, my reservation table, okay? And it's going to extend this other one called table. Now, already I've introduced some interesting things here. First of all, this is configuration. I only need to do this configuration one time in my application. I don't need to do it over and over. So in Kotlin, you can use an object. Objects are created just once. They're singletons. Okay, already we've gotten some benefits here, right? It's a nice way of expressing the fact that this information is only ever used one time. It also is a nice way to store what would be static information in a regular Java application, static variables, right? So that's my IDE, my ID for my primary key. And here's my name, right? My var car name field, right? And it's going to have a length of 255. So that's the table description. There's no XML config, no annotations, just a very nice way to work. And then I want to build a service to work with instances of that data. So I'll say exposed reservation service. And then this is just going to be a regular Spring Bean that talks to that API. And this service is going to do a few things. I'll have a fun to return, let's say, all of the data, all of my records from my database. So customer equals, and this gets really easy. So I want to talk to, reservation, right? I want to talk to the database and return reservation instances, okay? So this would be a plural, and then I'll have a class called reservation. And the reservation object has a field that's going to be an ID, which is an integer, right? We can see that, integer, or int rather, in Kotlin. I could do it like in Java. I could do name and string and all this, right? I could do that. The problem is, of course, I would need to make this nullable, and then I'd have to set up getters and setters and toString. Instead of doing all that, it's much better to use the succinct syntax. So I int, okay, and val name string, okay. So there's that. I don't need that anymore. And when I put it in the constructor like this, I get getters and setters. I'm using val. In Kotlin, val means it's an immutable final variable. If you use var, it's mutable. So very, very convenient, but I still don't have a toString and a hash code and all that. I can add data and I get that information. So now I want to get instances of reservation by using the configuration class, right? So reservations dot select all dot map. And here, my job is to take each result row object and turn it into a new reservation, right? Like so. And so I want to use the result row, and I can index into individual columns in my SQL database by using result row name. Now, of course, this works, right? It's what's upset. I have, what did I say down here? Integer, result row. Oh, sorry, it's not string. It's the actual thing from the metadata table. So result reservations.id and reservations.name. Okay, so I'm indexing into this object, and yet it's not an array. It's a result row. Operator. The Kotlin supports operator overloading. So already we've gained some niceness here. We've got nice DSLs. One thing that's very Java-like is to have a variable for the lambda. But in Kotlin, you don't need that. You can use the implicit variable called it. Okay. So now the other thing that's important is that this has to work well with Spring's definition of transaction demarcation, right? So what I'm going to do is I'm going to create a little component class, and I'm going to use the reservation runner. I'll just create a little bean here, a little Spring bean that's going to listen for an event. And again, if you don't know about Spring, what you need to know is that this is a callback. I'm just telling the framework to invoke my function when it's possible to do so, right? So I'm going to tell it to give me a reference in the constructor to this service, and I'm just going to use the service here to ask for the data, just so we can prove that the data access logic has worked, right? So I'm going to say all, and I'll just say for each, and I'm going to print out the results. What is this? For each. There you go. Good. Oop. Why is it upset? For each. Oh, loop parameter unused. Okay, yeah, print hit. Okay, good. So I'm just printing out the results as they're available. Now, keep in mind, this framework exposed has its own concept of a transaction. I need to participate in a transaction. If you're using Spring Boot, the exposed auto configuration automatically sets up the transaction and maps it to the Spring Boot idea of transactions. So all I need to do is to say transactional from Spring, and it just works. Again, very pragmatic. It doesn't force people to learn everything and do it a certain way, right? So we've already got a big benefit by using this kind of an API. Let's see what this gives us. Compiling for the first time. Up. And we can see we have to specify a connection to a database. So I'll say spring.datasource.password equals orders. Don't tell anybody. It's our little secret. Username equals orders. And URL equals Jdbc Postgres localhost orders. Okay. So already we've gotten some, it's familiar ground, and yet it's better in some ways, right? We've got this nice, amazing API from exposed. It's type safe. What's the issue here? Data source, JDBC Postgres. Oh yeah, PostgreSQL. Okay, now we have one more issue. Reservations doesn't exist. Okay, so PSQL, new orders, create table reservations, select all from reservation. Okay, so select all from reservations. Good, we got some names. Okay, there we go, my friends. Very simple example. And that's just using it. This is JDBC, and yet somehow it's more elegant, it's cleaner, it's type safe, and it's very fluid. I don't have any strings or XML or even annotations for the configuration of my domain model. I just do it in one place, and I get this nice type safe DSL that makes things easier. So this is one example of where using Kotlin can make things that feel old even more fun. You could also build a version using just the regular Jdbc template. The Jdbc template is an object that's been in Spring for a long time, and I'm not going to build a whole example here, but imagine you have a Jdbc template, and you say you want to create a new instance of it, like so, right? And here it's requiring a data source, right? So I'll pass in null. I don't actually care about the value. Let's see if I can do that. Yep. Okay, so now I've got a Jdbc template, and there are some very useful functions on here. But these functions, you can see, a lot of these were written for Java. So for example, look at the version down here where we have the SQL string, a callback handler, and then the variadic array of arguments. This one right here is obviously for Java, because in Java, your variadic array of arguments has to be the last parameter of the method, okay? Well, in Kotlin, it's very convenient to have any callbacks, which are typically expressed as lambdas, as the last parameter, because when you do that, you can actually have the lambda live outside of the invocation, okay? So what do I mean by that? I mean, we say, select all from foo, right? And then you provide 1, 2, 3, and then you provide this. Well, this is not what the JDBC version from Java does, but you can see I'm trying to do it the Kotlin way, and the IDE is saying, hey, do you want to import this thing called org Spring Framework JDBC core query? I say yes, go ahead and import it. And what I get is something called an extension function. So if I command click on that, you can see there's this file called JDBC operations extensions.kt, right? This is from a Kotlin source code file. And it's a function. You see it says public fun, and it defines the full type, and then the signature of the function, and then the definition, right? Equals blah, blah, blah. So this is not code that lives in the original Java class. It's code that's been added to the signature of the Java class after the fact, all thanks to the magic of extension functions in Kotlin. This is another thing that Kotlin has done so well, is it makes it possible to take old APIs and make them more natural so that they work very nicely. So everything we've seen so far in this second section where we've looked at exposed and now the JDBC template, all of this is just about taking old APIs and making them a little bit more pleasant, a little bit more appropriate, a little bit more palatable, okay? Where I think things get really interesting, of course, is when you go back to the drawing board and you say, I want to use Kotlin, and then you decide to use some of the DSLs that are built for Kotlin first, okay? So what I'm going to do is build a reactive web application that talks to R2DBC using PostgreSQL, and I'll use Spring Cloud Gateway, okay? I'm going to use Kotlin, and we'll hit generate. Now this is going to show some of the very nice DSLs that aren't just extensions or slight revisions or different APIs that use old APIs. These are brand new APIs that were designed with Kotlin in mind. And there you get to you can see that Spring, as wonderful as it is, looks completely different. It looks like a completely different framework when you start to use these really advanced DSLs. And I think that's where some of the biggest opportunities are for us today, is Kotlin's a rich language. It's possible to express very nice DSLs that we just couldn't do nearly so nicely in regular Java. So let's take an example here. Let's say I wanted to define a reactive HTTP endpoint, okay? Well, in in Java, I could do something like this. I would create a function, and then I return a router function object, and that router function is typed to server response. And then here, I need to return the function, the actual definition of the router function, okay? So I'm going to use this fluid DSL. I'll say .get / reservations. And here, I need to provide a HTTP handler function, right? And in the handler function, I have to return a response. Well, in order to produce this response, first of all, I need some data access logic, right? So we're going to talk to our database. But this time, instead of using JDBC, we're going to use a reactive non-blocking API called R2DBC. And we're going to use Postgres, not PostgreSQL. And then, the username will be just orders as before. Orders. And the password will be orders, okay? Good, so there's this. Now I need to define a repository to handle the data access. So I can use Spring Data Repositories, and I can extend the reactive CRUD repository, okay? And here I'm going to define an entity of type reservation, data class reservation, val ID int, and a val name string. Okay, so there's this data class and the repository to manage it. I don't need integer, that's a Java-ism, int, okay? and I want to create an endpoint that returns a single record, so ID, okay? Now inside of here, I can say I want to inject my collaborating object. I want to inject the repository. So RR reservation repository. I'll say return server response dot OK dot body, and I'll say rr.find by ID, and I want to get access to the current request. So again, I can just do the Java way like this, and I say request path variable ID, and I can turn this into an integer. So integer dot parse int. Okay, we've already the second parameter here. The second parameter after the repository data is the type of data that I'm sending back, which of course is a reservation, right? Like this. So get rid of that. There we go. There we go. That's my Java-like HTTP endpoint. But there's so many things that are wrong with this. First of all, this is a function. By the way, in Kotlin, when you have a function inside of a class, it's called a member function. When you have a function outside of a class, it's just called a function. We don't really call them methods, okay? So first thing, I have a function that has an opening, and it starts, and then it produces an expression, and it returns that expression immediately. So why bother having all this unnecessary redundant information? The compiler already knows what the return value is. So I can just get rid of that, get rid of this, get rid of this, right? Because there's no question in the compiler's mind as to what's going to happen. It's going to be whatever the result of this is. Okay, better. Second of all, I can get rid of that. I can remove that, right? That's fine. I don't need this. We know that we can use it, right? This class literal, this is called a super type token. It's a very well-known pattern in the Java ecosystem. But I don't need that because there are extension functions, and because Kotlin can capture generic information at runtime through those extension functions. So for example, here it says public inline fun reified T. I'm capturing the generic information at runtime. Okay. And then finally, the body that's being produced here. Let's see. This can be just by itself, right? I can just get rid of that. Sorry, whoops. I can get rid of all this.
Josh, popping in for a second to mention that we only have a couple of minutes left.
No problem. Okay, so I can get rid of that, and that's fine too. But even there, I can go a step further. You see, we've shipped a DSL that you can take advantage of that makes it even easier to use this stuff, like that, right? So now I'm getting this. There you go. Doesn't it look better? Now this is fine. I like this style, but we can go one step further. In Kotlin, we have something called coroutines. Coroutines are a way of describing asynchronous control flow without having to write asynchronous control flow logic. It's kind of like async await in Rust, C#, JavaScript, Python, and so on. And so in that world, it's very useful to be able to await a value. So here's what I'm going to do. I'm going to take this reactive stream, this date result, right? And I'm going to await it. And in order to do that, I need to use a coroutine aware router, right? So co-router. Okay. So I'm going to await this value. I'll say await first. Now I don't have, because before, what I had before was a publisher of reservation, right? That's what you get if you just leave this off, right? A reactive type, it's like a publisher or a promise or something like that, a future, right? Or mono, this is like a future, but I don't want the future. I want the thing itself, right? So what I'm going to do is use this compiler trick to just await for the value, right? It'll actually stop the function, free up the thread, and then let me work with it directly. So now instead of using a mono of reservation, I have just an actual reservation. And so now I can say body value and await, right? I can pass that in. So it's doing the same non-blocking thing. It's freeing up the thread, just like an event loop in Node or whatever. But now I have this very succinct syntax. So in this way, my friends, I hope you can see that the Kotlin language goes from simple, it can make your life better as a better C++, as a better C, as a better Java, and it can go very incrementally from that to better, to some more sophisticated DSLs, to more elegant extensions, and eventually to full-on DSLs like this. We have lots of examples of DSLs that are native Kotlin APIs that start with Kotlin in mind, and that makes the experience a lot better. Thank you so much for your time, everybody. I'm very happy to answer questions, and I encourage you to find me on the internet if you should be so inclined.